So good morning guys. Today we will gonna study about exposure. So first of all, exposure is denoted by letter X. It is only measured in air, and it is the amount of charged particle produced per unit mass. When an radiation, mm, when a non-particular radiation travel through the air, like X-ray and gamma ray. So, how exposure is produced? When X rays or gamma rays travel through air, so what happens? It ionizes the medium. So, the ionization charge, that charge produced, mm, is and divided by the mass of the air is known as exposure. But please note that to define exposure, we just have to take a charge of single sign. Like either you can take electron, or you can take um, positive charge. So exposure is dq by dm, and its unit is or coulomb per kg. And one more important point in exposure is that um, we can only find it for radiation, for photon whose energy is less than 3 MeV. Now let's talk about Kerma. So Kerma stands for kinetic energy release per unit mass. It is also a dosimetric quantity, and it is the sum of total kinetic energy of charged particle produced when an indirectly ionizing radiation travel through matter. So indirectly ionizing radiation such as photons, X-rays, or gamma rays. And the benefit of Kerma is that for exposure there is a limit beyond which, energy of 3 MeV, beyond which we cannot find exposure. But in case of Kerma we can find it easily, but it is only applicable for indirectly ionizing radiations like photons such as X-rays and gamma rays, as I already said. And there are two types of Kerma: collision Kerma plus radiative Kerma. So the contribution of dose in the medium is only because of collision Kerma, and the radiative Kerma, the energy escaped the medium. Example, when an X-rays travel a medium, it ionizes the medium, and that ionization, we can say example as the medium as body, a person body, human body. So what happens that when X-rays travel in human body, so it ionizes the medium, and the electron produced, that electron further its energy in the medium. So what happens at the time, that some of the energy being generated through characteristic radiations or Bremsstrahlung radiations, so that is radiative Kerma, because that part does not contribute in the patient dose, that energy just escapes the medium. And in the last we will gonna study about absorbed dose. It is denoted by letter D. So it is the amount of radiation that is absorbed in the body, and it is equals to K collision. For example, if there are 7 students in the class, and teacher is delivering the lecture, so teacher is delivering the knowledge, so that knowledge is known as exposure. Now it's up to student how much knowledge they can gain what teacher is delivering. So the gained knowledge is known as absorbed dose. In the same way, exposure is the amount of radiation, and absorbed dose is the quantity that the dose that the medium receives. There is a benefit of absorbed dose is that it is applicable for directly ionizing radiation as well as indirectly ionizing radiation. As in exposure and Kerma, These quantities are only applicable for indirectly ionizing radiation, but the absorbed dose is also applicable for directly ionizing radiation such as electrons. Thank you.